Hey guys, all right, we're gonna do notes 3, graphing rationals and their key features. So we're gonna use what we know about graphing and try to find these key features of rationals. So the parent function for rationals is 1 over x. Okay, so any other changes to it will change all those key features. So it's really important you understand that this is the parent function. We've talked about that before. So x and y intercepts. So to find them by just looking at your equation that you have, looking at your function, to find your x-intercepts is when the top of your fraction is equal to 0, okay? Because this is when y is equal to 0. So if the top is equal to 0, that's where y equals 0, which gives you that x-intercept, okay? So to find your y-intercept, what we're going to do is we're going to set all of our x values equal to 0 and then simplify. Okay. So we're going to do those two things with these these equations that we have, these functions that we have. So for the first one, we're going to find the domain, but we're also going to find the intercept. So the domain for this first one, number 1, remember domain deals with your x values. So you need to decide what x can and cannot be. Okay, so for this, we're going to look at the bottom. X cannot equal 4 because it makes the bottom 0. So your domain here is going to be negative infinity, positive 4, union, positive 4, positive infinity. Okay, and when we talk about asymptotes, that's why the domain is like that. If it can't equal 4, it's going to skip over it. So for this first one, if we're looking for our x-intercepts, okay, that's where the top is equal to 0. So if we set the top equal to 0, it's 0 equal to 1, and we can't have that. 0 can't equal to 1, so there's no x-intercept. Okay, so there's no x-intercept. So for y-intercept, we set the x is equal to 0. So anywhere there's an x, you're going to plug in 0. So for our y-intercept, it's 0, negative 1/4. And you're going to have a lot of fractions here for your y-intercept because we're dealing with functions that have fractions in them. So if your function is not factored, you need to factor it. We're going to go over here and do number 2. This one's already factored, but if you're not factored, like number 3 that I'll have you do is not factored, you need to make sure it is factored. So this one is, so the first thing we're going to do is we're going to take a look at our domain. Remember, domain is where x can and cannot be. So we'll look at the bottom. X cannot equal 3. Negative 3, and x cannot equal 7 over 4. So if you solved for these factors, set them equal to 0, you would get x equals 7 over 4. X can't equal those things. So your domain is going to be split up into some chunks. So negative infinity to negative 3, negative 3 to 7 over 4, and union 7 over 4 to infinity. Okay, so for rationals, this is pretty typical that the domain in your range would look a lot like this where it's split up. So now when we're just looking for x-intercept, x-intercept is when the top is equal to 0, so we have 3x plus 1 and x minus 2 that's equal to 0. So x here can equal negative 1/3 and positive 2. So those are your two x-intercepts. And then for your y-intercept, again, you're plugging in 0 for all x values. Okay, so we're going to go ahead and do that. And then you're going to simplify these expressions so you can get an answer. So 3, anything times 0 is 0, so now we have 1 times negative 2 in the top, and 3 times negative 7. So here your y-intercept is 0, and then 2 over 21. Negative 2 over negative 21 is a positive. So those are your intercepts. So what I would like you to do is, using the information we just did, we're gonna cross number 4 out. We'll put a new one in there for number 4. I want you to try to do number 3. You're gonna need to factor first, like we just talked about, and then you're going to find your domain, and then your intercepts. So both x and y. So go ahead and do that now. All right, so for this one, your factoring should be -3, -4, and +4 and +5. So then your domain, x cannot equal -4 or -5. So -infinity to -5, to -5, -4, and then -4 to infinity. So then for your x values, if you set the top equal to 0, you should get x is equal to +3 and +4. And then for y-intercept, if you set all your x values equal to 0 and multiply through and divide, you should get 0 and 3/5. So you guys have to know this because you do have a no calculator section. So you do need to know these properties and how to find them. So I want you, for number 4, I want you to write this function in there. So the function f of x, x squared plus 2x plus 1, all over x squared minus 5x plus 4. I want you to try the same process again. You're going to factor, find the domain, and then find your intercepts, just like number 3. So I'm going to leave it in the frame. So go ahead and do that now. All right, so when you factor, you should get +1 plus 1, -1 minus 4. Then you have your domain, what x can't equal. So x can't equal 1 or a +4. So -infinity to 1, 1 to 4, and 4 to infinity. So then your x-intercept is -1 and your y-intercept is 1/4. Okay, so just let me know if you have any questions. Check your work, and we're gonna scroll down and talk about horizontal asymptotes. So an asymptote itself is just an invisible line that the function isn't supposed to cross. So horizontal asymptotes, actually, some functions cross them. I don't know why that is. I will probably find out at some point. But these are the qualities that tell you whether you have one. So if you have an invisible horizontal line that's a boundary that it may not cross, these are the 3 characteristics. Okay. So if the powers are the same in the top and the bottom, you're going to divide the coefficients. Okay, that's the first thing. So if you're looking at your leading coefficients, if the powers are the same, then you're going to divide the coefficients, and that's where your horizontal asymptotes are. And a horizontal asymptote is where y is equal to something. So then the second one, if the powers of the leading coefficients are larger in the denominator, your horizontal asymptote is equal to 0. And if the powers are larger in the numerator, then there is no horizontal asymptote. So we're going to go through and figure out what we have, what we don't. We're only going to do the asymptotes for number 1. Okay, that's what we're doing for number 1. We're only going to do the asymptotes. And the biggest thing is, it doesn't have to be factored for you to be able to do this, but if you're asked to find like the intercepts and the domain, then you do need to factor. Okay, so for number 1, we're just going to do your HA, your horizontal asymptote. So with that, we look at our leading coefficients, so the coefficient with the highest power for the variable, and they are the same here. And so because they are the same, you take the coefficients and divide them. Okay, so if you had to reduce, you could. So if you need to, you can. But we have a horizontal asymptote at y equals 2/3. Okay, so that's what we're going to be doing. So for number 2, we're going to be finding all of the stuff that it's asking for. Actually, we're only going to do intercepts. We're not going to do domain. We probably we'll do domain for 3 and 4. So here for intercepts and horizontal asymptote, let's find our x and y's first, and then we'll find our HA. So x-intercept when the top is equal to 0. So if you set 3 squared minus 3 equal to 0, what would your x value be? So your x-intercept here is a +1. And then if you set all of your x values equal to 0 to get your y-intercept, you should get -3, okay, because it's really -3 over a +1. And then for your HA, you're looking at your leading coefficients, okay? So the degree in the denominator is 3 and the degree in the top is 2. So when the degree in the bottom is larger, then you have an HA at y equals 0. So if you know these characteristics, it makes these problems go by faster. So we'll do one more together. We're going to do number 3. So number 3, we're going to do all the characteristics because it's factored for us all nice. So we'll do our domain. Okay, so domain for this first part. Okay, so domain is where x can and cannot be. So x here cannot equal a -1 or a -4. So for my domain, -infinity to -4, union -4 to -1, and then -1 to +infinity. These are pretty much how rationals are going to go. So then your x and y intercepts. Okay, so if the top is equal to 0, what do your x-intercepts? What are they? What are your solutions? So x here is going to equal +1, or it's going to, and because it's solutions, -3 over 2. And then your y-intercept is when all the x values are set to 0. So when you do that, you end up with -1 times a +3, which is -3, bottom 1 times 4. So your y-intercept is 0, -3 over 4. And then the last thing we're going to find is we're going to see if we have an HA or not. So to do that, when it's factored, you need to look at all of the x values and see what power they are. So here, the top would give you a square, and the bottom would also give you a square. So that means because the leading coefficients, the powers are the same, we're going to divide those coefficients. So if we're dividing those coefficients, it's 1 times 2 over 1 times 1. So there's a horizontal asymptote at y equals 2 over 1 or 2. Okay. So what I would like you to do is I would like you to do number 4 on your own. So if you can't factor it, that's fine. It doesn't look like you can, but if you can factor it, you should. But find all 3 parts: domain, intercepts, and your horizontal asymptote. Okay, so go ahead and do that now. All right, so for number 4, the domain is x can't equal -1. So you should have -infinity to -1 and -1 to +infinity. Here, there is an x-intercept, but it's an irrational number. You can't find it with how it is, so you can only find the y-intercept without a calculator. So I would only ask you to do that. So here your y-intercept is 0, 2. And there's no horizontal asymptote because the degree in the numerator is greater than the degree in the denominator. Okay. So I'm going to end the video here. The next part we're going to talk about is vertical asymptotes and holes. So that could take a little while. So I'm going to go ahead and end this one here. Have a good day.